Hey everybody, so quick video on the PowerPoint. Now, this goes along
It's
with
10 o'clock.
the assignment due on Wednesday. So you can either just go through the PowerPoint on your own, or if you want a little bit more detail on the slideshow, you can use this video. Okay? So, just an introduction to evolution. This here is actually Charles Darwin, who is not the discoverer of evolution in general, but he did figure out the driving forces of evolution. So he figured out what's called evolution by natural selection, which we're going to discuss. And the way he came up with his theory was through a long journey that he was a part of around the world on the HMS Beagle. That in itself is kind of a long story. There's a lot of different pieces that I think are kind of culturally important to understand. There's a few that we'll talk about in this PowerPoint. So his idea of evolution by natural selection, I'm going to jump around just a little bit here, is really based off of this guy's previous explanation of evolution. So evolution is this idea that species change over time, right? Slowly over time. Now, Jean-Baptiste Lamarck, he was a scientist who believed that species evolved by acquiring their characteristics. So a common example of this is he said, all right, a giraffe has a long neck because when they had babies, the babies had to stretch a little bit further every generation to reach the leaves up in the trees, and that made their necks stretch out longer, and they passed on that acquired characteristic to their offspring, so it got longer and longer and longer, which we know today is not true at all. Okay, and so evolution that we understand by natural selection, what Darwin said, is kind of based off of Lamarck's false theory. So it was important that we had this theory to build a better theory off of. There's a few other things that were important here too. So these are all scientists who had ideas that helped Darwin build his own idea. So first is Charles Lyell, uniformitarianism. Uniformitarianism means that the Earth changes slowly over time. So like the Grand Canyon didn't form in 100 years. It probably took hundreds of thousands, if not millions of years. So before Charles Lyell, most people believed the Earth was a couple thousand years old, which is not long enough for evolution to really occur. When Lyell came around, he basically told the scientific community, no, the Earth is millions of years old, all right, billions of years old now, but that gives a lot more time. Georges Cuvier, he was the first scientist to really explore the idea that not everything on Earth today has been here forever, and there's been species that were here before that have now gone extinct. It used to be believed that everything you saw is what was here when the Earth formed, and he basically came along and said, no, there's some species come and go. So extinction is important. What that does is it opens up habitat for new species to take over. And Malthus was a mathematician who basically came up with the idea that if food shortages happen worldwide, humans are going to have to struggle to exist, and those who are best able to struggle and win the battle will get the food and survive. So survival of the fittest. That's what Darwin really got that idea from. So these four gentlemen really helped to drive Darwin's idea. Now, Darwin sat on his idea for most of his life. He had this idea formed in his, I think, in his 20s, maybe early 30s at the youngest, but he didn't publish his ideas until he was about 80. And he did it because this fellow right here, Alfred Wallace, came up with the almost identical idea of Charles Darwin, and he sent a manuscript to Darwin saying, here's how I think species evolve. What do you think? And when Darwin read it, he realized that this guy had come up with the exact same theory as he had for decades been working on. So what he did is he got back in touch with Alfred Wallace and said, let's publish together, and they both did. Usually we don't remember Alfred Wallace too much because his evidences were pretty new. He didn't have a lot, whereas Darwin had already written a book that he hadn't published yet that was, very detailed. So Darwin had a lot more proof to go with his. Now, I'm kind of gotta skip through this part pretty quickly, but there's this idea of evolution. Like, does evolution occur slowly, gradually over time, or are there, everything stays the same, and then all of a sudden there's this huge event, like an earthquake or something, that kills off a lot of the species, and all of a sudden that event has changed what that species looks like and behaves like from here on out. That's called punctuated equilibrium. And the idea behind this too is that, things, species do go extinct. There's not, when you look at all the species that have ever existed on Earth, there's not a lot of them around today. 99% of all species that have ever existed are now extinct. And there's been several mass extinctions. There's been 5 mass extinctions. This one right here is the most recent, is the one that we know of as the dinosaurs going extinct, but there's been several in the past. This one wiped out almost all life on Earth, very close to making Earth back into a state where there is no life. And some scientists believe that, we are actually in a mass extinction right now. That's when you have some sort of change in environment. So Gary Larson's a great comic, one of my favorites, and this is just a good one showing the mass extinction of dinosaurs that were cold-blooded, and here comes the snow, and they're laughing at the mammal, but we're warm-blooded. Now, whether that's how the extinction really happened is debatable, but it's a good comic. But so right now we're having huge changes in our climate, and there's a lot of factors involved, but scientists agree that we're actually in a 6th mass extinction right now. And that's something maybe we could talk a little bit more about later. So now what I want to get into is the evidences for evolution. So here's the first one, the fossil record. So we can actually look at fossils. So here's some fossils of horses, and we can see how horses have changed throughout time. All these different branches coming off of this are different kind of species of horse and how it's changed. It used to be the size of a dog, and now, obviously much larger in general. A little side note, branching evolution, it's just something that happens when you take a species and put it into different environments. So these are called Darwin's finches. There were finches during his journey that he found off the coast of South America at the Galapagos Island. And those islands, these finch would actually, there'd be different finches on each island, and their beak shape changed based on the food that they were eating. So like these ones were maybe cracking seeds, these ones were burrowing into dead logs for insects. So you had much different beak shapes based on their habitat. All right, next evidence. Number 2, morphological similarities. Basically what that means is cats, even though they're different species, kind of have same body shapes. A couple side notes here. Comparative morphology, which is we're still on evidence number 2, is simply saying if you have species that are somewhat related, like these are all mammals, otherwise they're very different, they do have similar bone structures. So like the whale has the same kind of digits and fingers as a bat. Or there's something else called homology, which is basically saying if we have a common ancestor, which, here's humans and here's some primates, you tend to have very similar morphological or body shapes. So here's our hands, very similar. Third evidence, comparative embryology. These are the embryos of a whole bunch of different species. And you can see when you look at them, so these are still either in the womb or in the egg. They have very similar features. It isn't until they really start to develop that you start to notice the differences. Right? This is a pretty debatable evidence. Some people read into this more than what it really is, but it is one that we can use. It's interesting. Recapitulation is not an evidence. It's similar to this comparative embryology. What it's saying is that some species, as they evolve, will have certain body parts that go away during their developmental stages in the womb. So like Baleen whales are filter feeders, but in the womb they actually have teeth, and as they develop, the teeth go away into these filter feeding components. All right, I think we're on number 4. Vestigial structures. These are structures that are found on certain species that no longer serve a purpose. They're there because they used to serve a purpose in some ancestral species. And the fact that they still exist, they're still there, is proof of evolution. So an example, the appendix is something that is really not functional in humans anymore, although I think in the last few years there's been some research showing that it does have some functional components. But by and large, it's something that remains there because it was something that our ancient ancestors used to use before humans even really developed. Or like the legs, these are leg bones on a whale, showing that whales were once creatures that had front and back legs, and these have just kind of gone away, and they're still inside the whale, they're not really functional. Or the nictitating eyelid. So we have eyelids that open up and down. If you've ever seen like a chicken's eyelids that go sideways, we actually still have, this is the tear duct, but next to it, we still have the leftover vestigial structure of an eyelid that would go in this direction. Biogeography is another one that we can actually see how a species changes as it moves across the globe. So you can tell that they're very similar species, but as they moved, their environment changed and they evolved differently. And the last one is molecular evidence. So now that we have the technology to look at DNA, we can look at DNA and see similarities in species in their DNA and figure out how that is kind of an evidence of evolution having occurred. I think I said the last one. This is actually the last one. It might not, I don't know if there's room in your notes for it. If there isn't, you can put it in. One of the best evidences for evolution is we can actually watch it happen. When we spray fields with pesticides, it'll kill off most of the pests except for some that are resistant. And when they reproduce, all their offspring will have that resistance. And what they're doing is they're evolving to that pesticide. We see it in the medical field. Here's drugs being used to treat people with HIV. At first it works, but then the virus becomes resistant. It evolves and it's no longer able to work, right? So right there, we're going to end there. If you continue through, it's not really going to connect to our notes. It'll be something that we do more next week. So keep an eye out for another video coming out for the assignment that's due on Friday. Okay, bye.